If you bought a home built between 1965 and 1973, you may have paid $250,000, $400,000, or more for a property that has a fire-starting mechanism wired into every outlet in every room. That is the documented finding of the U.S. Consumer Product Safety Commission, also known as CPSC, and the wire they identified is still sitting in roughly 2 million American homes today. The strangest part is not that it fails. It fails in a way the circuit breaker was never designed to detect. The culprit is aluminum branch wiring, most notably the AA1350 series installed in the late 1960s and early 1970s, and later AA8000 series alloys. Aluminum conducts only about 61% of the current of copper at the same gauge. It expands and contracts about 35% more with temperature. It oxidizes into an electrical insulator, and it exhibits cold flow, so connections slowly loosen. Loose connections heat up, with recorded faceplate temperatures over 300 degrees Fahrenheit, and can ignite without tripping a standard breaker. Some tests recorded a 55 times multiplier in failure measurements compared with proper copper connections. The only CPSC validated fix is a copalum cold weld repair, which costs $50 to $100 per connection and typically $5,000 to $10,000 per house. A full rewire can cost $8,000 to $30,000. Common pigtailing is less reliable, and AFCI protection was not required until 1999, so those devices were not in place to catch this failure mode. If you are considering a house from that era, hire an electrician certified to work on aluminum wiring, or consider avoiding homes built from 1965 to 1973. In 1965, the Vietnam War was driving the price of copper up, and copper was what every house in post-war America had been wired with. Builders were looking to keep their margins, and the alternative they landed on was aluminum, specifically AA1350 series solid aluminum branch circuit wire, which runs from your electrical panel out to every outlet, switch, and light fixture. The savings were in the hundreds of dollars per house in the 1970s, multiplied across an entire suburban building boom. Homes with original aluminum branch circuit wiring are roughly 55 times more likely to have a connection reach fire hazard conditions than homes wired with copper. 55 times. Not 55%, 55 times. Failure point 1. The wire itself is the wrong metal for the job. Aluminum carries roughly 61% of copper's current at the same gauge, so to do the same job, the wire has to be physically larger. That alone was not the problem. Aluminum's thermal expansion rate is roughly 35% greater than copper's. Every time current heats it, it grows more, and every time current drops, it contracts more. Aluminum oxidizes the moment it touches air. Aluminum oxide is not a conductor. It is an insulator forming on the surface of the conductor. Aluminum also exhibits cold flow, the metal slowly deforming under sustained pressure, even at room temperature. Every aluminum wire installed in 1971 has been quietly squeezing itself out of every screw terminal for 50 straight years. A full rewire costs $8,000 to $30,000. The wire itself is fine. It fails everywhere it touches anything else. Failure point 2. The connections cook themselves alive, slowly, over years, with no warning signs. Every outlet, switch, and junction is a connection point. When you turn on a hairdryer, the aluminum heats. Because aluminum expands more than the steel screw holding it, the wire pushes against the screw harder than steel can resist. When you turn the appliance off, the wire contracts more than the steel does. Every appliance, every cycle, every day, for 50 years. Each cycle slightly loosens the connection. A loose connection has higher resistance. Higher resistance dissipates more heat. More heat causes more expansion and contraction, more loosening, more heat. The loop accelerates itself. Layer on the aluminum oxide forming inside the connection. Recorded faceplate temperatures at failing aluminum wired outlets have exceeded 300 degrees Fahrenheit before ignition. The remediation method validated by CPSC field testing is the copalum crimp, a cold weld connector applied with a specific calibrated tool, and it runs roughly $50 to $100 per connection. A typical single-family home has several hundred connections. The total job runs $5,000 to $10,000, and only electricians with the certified tool can do it. This entire failure mode happens without ever tripping a breaker. Failure point 3. The circuit breaker is blind to the way aluminum wire fails. A standard thermal magnetic breaker is designed to detect exactly two things: overcurrent, drawing too many amps for the rating of the wire, and a short circuit, a direct fault to ground or neutral. A loose, high-resistance aluminum connection does neither. It dissipates heat at the connection point itself, while the current passing through the circuit stays inside the normal range. The breaker reads normal amps and does what it was designed to do, which is nothing. It will sit there, performing flawlessly to specification, while the outlet faceplate above it heats past 300 degrees Fahrenheit and the receptacle scorches and starts to melt. There is a different kind of breaker called an arc fault circuit interrupter, AFCI, which listens for the electrical signature of arcing. AFCI devices were required by code in bedrooms starting in 1999. None of them existed when these homes were built. The receptacle melts before the breaker knows there is a problem. So who is responsible? The volume builders of the 1965 to 1973 era were not malicious. They were rational actors, responding to a copper price spike with a cheaper alternative nobody had yet field tested at residential scale. By the late 1970s, the failure pattern was documented. The industry shifted to a different aluminum alloy, the AA8000 series, used in service entrance and feeder cables today, generally considered safe at those gauges. Problem solved. Going forward, the original AA1350 wire, the wire actually in the walls of those 2 million homes, was never recalled. There is no mandatory replacement program, no federal funding, no insurance pool, no developer liability, no home builder accountability. The wire stays in the wall until the current homeowner, who did not install it, did not choose it, and in most cases does not know it is there, pays out of pocket to take it out. The CPSC's official position is to recommend remediation. That's it. So what is worth doing? Number 3. If you're buying a home built from 1965 to 1973, hire an electrician with aluminum wiring certification to inspect every accessible outlet, switch, and the panel before you close. Not a generalist, not a standard home inspector, someone who knows the failure pattern and has done this specific work before. Number 2. If the home has aluminum branch wiring and you plan to live in it, the copalum crimp procedure is the only remediation method validated by the Consumer Product Safety Commission in field testing. Pigtailing with regular twist-on connectors was found to be less reliable. Number 1. Skip the ERA entirely. Homes built before 1965 were wired with copper. Homes built after roughly 1973 went back to copper. The 1965 to 1973 window is the only span of post-war American residential construction where the wiring itself is a documented fire hazard. A 1959 ranch on its original copper is a safer electrical system than a 1971 Colonial on its original aluminum. Some carriers will not write a new homeowner policy on an unremediated aluminum wired home, and the ones that will charge for it. If you currently live in a home from that era and you have never had the wiring inspected, pull the cover off any standard outlet. Turn the power off. Use a screwdriver. 10 minutes. If the conductor coming into the screw terminals is silver-colored instead of reddish, you have aluminum. Aluminum branch wiring in a home built in the 1970s is the only place in residential construction where the failure mode is invisible to the safety device that is supposed to catch it. The builder's incentive ended at the closing table in 1971. Yours started the day you bought the house. Next week, we are going inside the Federal Pacific Stab Lock panel. Millions of them are still installed in American homes. The breakers do not trip when they are supposed to. Subscribe so you do not miss it.